All right, so far we've been dealing with describing solutions, using reference tables, calculating stuff about concentrations, but we also want to take a second and look at what effects does a solute have on the properties of a solvent. So when a solute is dissolved in a solvent, the properties are attracted to the particles of the solvent. So this has several effects on the solvent. It's going to lower the vapor pressure of the solvent. It's going to elevate the boiling point of the solvent. And it's also going to lower the freezing point of the solvent. So when we're talking about the boiling point and freezing point, we're specifically talking about the solvent, usually water. All right, so we're going to look at these two examples. All right, on the left-hand side, I have pure water. That's my pure solvent. On the right-hand side, I have just dissolved sugar particles into the water. Now, the sugar molecules get in the way of, in this case, evaporation or boiling. It's going to take more energy for the vapor pressure to equal the atmospheric pressure, so it's going to cause an elevated boiling point or a higher boiling point. They have to get to a higher temperature. I can also look at the fact that when I'm going to try and freeze the water, the molecules of the sugar also get in the way of the solvent particles and keep them from coming together to form a solid. So the solution also has to move this extra energy, go to a lower temperature in order to freeze. So what we're going to also see is that the more solute particles in solution, the higher that boiling point is going to climb and the lower that freezing point is going to fall. And sometimes students have a little bit of trouble understanding this. So if this was my solvent only, and the melting freezing point was 10 degrees Celsius, the boiling point was 80. So you'll see you have only a liquid from 10 degrees Celsius to 80. If the boiling point gets raised when I add the solute, and it goes up to 85 and the freezing point falls to 5 degrees, you can see that it's now a liquid from a lower temperature to a higher temperature, 5 degrees to 85 degrees. Something just to kind of keep in mind. All right, this has an important impact in our daily lives, especially in the winter. This is why we're going to salt roadways. I'll show you guys something about that. Why you use antifreeze in your car to keep it from overheating or from freezing. So we'll tie back into this in class. So how do we figure out what might have a higher boiling point or a lower freezing point for our solvent and their different solutions? So the first thing is looking at concentrations of the same substances, and by same substance I mean the solutes that's being dissolved. So the higher the concentration of the solute, the higher the boiling point and the lower the freezing point. So if I had this example of a 2 molar sodium chloride solution and a 5 molar sodium chloride solution, and I was asked which solution will have the lowest freezing point, the lowest freezing point would mean the biggest effect by the solute, so you want the highest concentration, which would be the 5 molar. The other factor is electrolytes versus non-electrolytes. What we find is that solutes that can break up into smaller pieces, ions, when they dissolve, will have a greater impact on the freezing and melting point. So electrolytes, which are going to be any ionic compound, so metal and nonmetals, or acids, which while they're molecular, we're going to find them on table K because acids can ionize and produce ions in solutions. So any electrolytes are just going to include those two groups, and electrolytes produce ions when they dissolve. Non-electrolytes, which is going to be any other molecular compound besides acids, do not break up into ions. The molecules themselves stay together. So if I look at two examples, I put in 3 compounds of sugar and of sodium chloride. When I put in 3 particles of sugar, the sugar molecules themselves stay together, so I still have 3, which is fine. However, when I put in sodium chloride, those NaCl's break up from each other. So I don't just have 3 particles, I now have 6 because of it breaking up. So since electrolytes come apart and create more pieces, their boiling point elevation and freezing point depression is greater than for molecular substances, and this is really important. So let's look at 3 examples, and I've kind of made this column more detailed than it is in your note packet, so I would make sure you kind of edit that and update that. So these are all 1 molar solutions, so I'm putting in the same concentration, which is important here. So that allows me to just look at the formula. The first thing you have to think about is it ionic or molecular? Well, C12H6O12, interesting, I think I typed that in wrong, should be C6H12O6. Somehow that got inverted. This is molecular. Oh boy. If it is molecular, and as long as it's not an acid on table K, it's going to be a non-electrolyte. So it's going to stay as one particle in solution. If I take a 1 molar sodium chloride solution, I have a metal and a nonmetal, so it's ionic. And ionic compounds are going to be considered electrolytes. So we want to look at the formula for NaCl. Keep an eye out for any polyatomic ions that would have to stick together. NaCl does not. So NaCl would break up into a sodium ion and a chloride ion, so 2 particles. However, I look at sodium carbonate on the bottom row. This is ionic as well, and it's an electrolyte. CO3 is a polyatomic ion that will stay together, but that 2 after the Na indicates I would have 2 sodiums. So Na2CO3 is going to break up into 2 sodium ions and 1 carbonate ion. So this gives me 3 particles. So when comparing these 3 different solutions of the same concentration, because they're breaking up into different particles, they're going to have a different effect. So which has the highest boiling point and the lowest freezing point when dissolved? It's going to be the one with the most number of particles. So this aqueous solution has the highest boiling point and the lowest freezing point. So you want to be on the lookout for concentrations, and you want to be on the lookout for any electrolytes that will break up into more particles. Because the more particles a solute breaks up into, the more ions, the higher the boiling points, the lower the freezing points.